So we're going to jump into this presentation. We're going to talk about what Supra is bringing to market, something that the world has not seen before, but is very natural evolution of technology and especially blockchain technologies. So I'm Josh, I'm co-founder, CEO at Supra. We're going to be presenting today a new framework, a new architecture that enables a single blockchain to do many, many things that allow smart contracts to be more expressive and to just be more, create more value for the world. So let's start with the problem, right? The problem is that most decentralized applications today have to run through multiple networks. A smart contract platform can do more things if it can plug into an Oracle solution, if it can have access to price feed data. A smart contract platform, in the context of a multi-chain world, needs bridges or cross-chain communication protocols. Many gaming applications or on-chain lotteries and games of chance need on-chain randomness. Blockchains are deterministic closed-loop systems. They don't speak to the outside world, nor do they speak to other chains themselves, yet we try to call them world computers. Also, there's other things, such as automation, a decentralized if this or that network. Blockchains don't offer this out of the box. This is usually an external network or an Oracle that does this. And we ask ourselves, what if we put it all in one? Why can't we do this? Now, the problem gets worse in the modular stack. I know a lot of you folks are Ethereum aligned. We are too. We are going to be EVM compatible. However, I want to remind you all that the Layer 2 strategy was not something that folks had originally planned for. This was an emergency pivot. So back in the day when I got into blockchain, early 2017, it's been about 7 years. Back then, the whole talk was about going from proof of work to proof of stake. That was going to be a big transition, and they did that. And give credit where credit's due, and they did a wonderful job. But the next plan was a sharded architecture. It was something like 1,024 shards. I don't agree with that design decision, frankly, but I think it was still better than what we're doing today, unfortunately. Now, move forward to 2019, 2020 era, with the advent of high-throughput chains like Solana, AVAX, Phantom, Ethereum had to make an emergency pivot to a Layer 2 strategy. I want to remind you folks that this is not something that they wanted to do originally. This is more of a design decision, a pivot that they had to do to compete. Okay, so that's a little bit of a stroll down, the history of this is all verifiable. It's absolutely true. Now, the problem gets worse, though, right, in a modular stack. Because now you have a Layer 2 that's doing execution, a Layer 1 for settlement, right? But you still have to utilize a data availability network. That's a different network. You still have to use a different network for price feed oracles, on-chain randomness, cross-chain communication. These are different, disparate networks. And as a result, your application, if you use any of those services, you don't have Layer 1 security anymore. You have the security of the weakest component. So once again, multiple networks weaken the stack. You have builders that have to shoulder more costs because they have to juggle multiple tokens. You have broken security guarantees. This is not Layer 1 security anymore. You also have more latency. It takes longer to finish the protocol because you have to send the request out from one network to another. That network has to finish its consensus or agreement. Then it has to send you back the response. So it's actually slower. Don't let anyone tell you differently. Developers, you have to learn different frameworks. You have to learn different programming languages and juggle multiple tokens. This is complex, and it's just not a seamless experience. What we're doing is building a vertically integrated, fully integrated Layer 1. Why can't a Layer 1 be high throughput, low latency, have data availability, have native price feeds, have ability to have cross-chain communication with Layer 1 security, have automation, have on-chain randomness? Why not? If different networks can do it, there's no reason why a single network can't do it, unless, of course, you need to have a very clever network architecture. And we're going to be introducing that to you today. So what is a fully integrated blockchain? Well, imagine a blockchain that has support for multiple virtual machines. So let's think about this. We talk about world computers, right? And this is just a decentralized, distributed computer. Why can't the hardware run multiple different forms of software? Why can't it run different virtual machines? Your computer at home can run iOS and Windows and Linux. Why don't we run multiple VMs on the same blockchain? Automation, once again, zero block delay automation, a decentralized if this or that. Many of you don't know that this doesn't happen right now. And when we look back on this in the future, we're going to be like, wow, blockchains really did not have that much capability. They only had the ability to do consensus and ordering and smart contract execution. But automation enables all kinds of use cases. One of my favorite use cases is like micro subscriptions. Subscriptions below 30 cents or anything that Visa and MasterCard is too little for them to want to handle. That's a whole new world that we would love to tap into ourselves. Cross-chain communication. There are many bridges out there. We know that bridges are probably the most vulnerable part of the blockchain stack. Our designs are designed to be cryptographically secure, to have layer 1 security when we communicate from one layer 1 to ourselves to others. This is done pretty simply once you see it. Once again, some of these ideas, in retrospect, you'll see they're so obvious. What we do is we just need to recompute the consensus of the chains we interact with. In the proof-of-stake world, you have to put up a stake, you register your node ID, that information is known. And if we have that information relayed to us, we just need one single honest node to give us this information. And we cryptographically prove and check that that chain itself has full consensus on this information. So why not just recompute the consensus of the chains we interact with? That's layer 1 security, and it's fast. Price chain oracles. This is, many of you know us as Supra oracles. When we were speaking to our early investors, we told them we're going to market as Oracle, but really our goal was to roll out a vertically integrated stack, a layer 1 with price chain oracles and beyond. I do want to mention the Oracle problem is actually very, very extensive. Consensus, sure. There's different flavors of consensus. This or that BFT. Supra has moonshot consensus. By the way, for classical consensus algorithms, we're confident that this is a limit, that others are not going to be able to perform better than this. Now, these networks, right, the Oracle problem is bridge. Actually, that's part of the Oracle problem. Cross-chain communication, automation, on-chain randomness, price feeds. These are all part of the Oracle problem. So what we embarked on over the last 4 years was actually more difficult than just trying to roll out a new layer 1, because we had to design from scratch new protocols and algorithms. Now, finally, to power what's probably, in my opinion, going to be one of the major ways for blockchain to go mainstream is GameFi, gaming. Sure, a lot of components will be in Web 2, and that's fine. But in terms of value transfer for asset management, those things really ought to be controlled, or rather handled through a blockchain, where value is valuable, right? So we asked ourselves, well, can we build an infrastructure that can handle everything in one, at least the core components? And of course, anything like the folks at EigenLayer are bringing through restaking, these are forms of verifiable compute. Supra being a layer 1, we can do this too, and we will. How do we maintain security across all these different services, though? In the end, the whole thing is moot unless we have security. Security is always number 1, okay? But what we do is we shuffle the nodes periodically. Compared to other networks, we do this very often. And why is this important? Well, the unpredictability of which nodes at any given time are doing which service makes it very difficult for an adversary to attack or plan an attack. Now, we randomly shuffle those nodes into clans. Clans are subcommittees of the tribe. The tribe is the entire network. We shuffle them into subcommittees called clans. Each clan can be doing a different service. And every cycle, the services that these clans are doing can actually change. The hard work of performing what's called a DKG, a distributed key generation, a key exchange ritual, is usually somewhat cumbersome, but Supra's wonderful researchers have innovated something called class group DKG. This is the benefit of working with world-class cryptographers, literally some of the best in the world, on Supra's team. So we can afford to shuffle the nodes and perform DKG often. This is very, very important for network security. Talked about Moonshot. We're not the only one that can do high throughput, low latency. In our test of 300 nodes, we hit 500,000 transactions per second throughput with sub-second consensus finality. So when I say consensus, I'm talking about ordering, like finalized order of the blockchain. How do we do this? Well, once again, it's one of those things, once you see it, it's simple. Every node in Supra can be a batch proposer. They can propose a batch of transactions that can consist of thousands of transactions. This test was run on 300 nodes globally distributed. You have to account for the latency, the speed of light limits of any global system, which is roughly 133 milliseconds for a round trip. Now, if every single node on Supra is proposing a batch simultaneously, oh, by the way, I should mention, this is a huge insight that Supra has found that other blockchains have not. We have known that, the industry has known for 4 years, decoupling execution from consensus has benefits. To my knowledge, we're the first one to decouple data dissemination from consensus. Decoupling data dissemination from consensus, decoupling execution from consensus, leads to what we believe is basically the maximum limit. So imagine every single node around the world could propose a batch of transactions. It gets really interesting beyond this, though. We also realize the data dissemination itself only has to go to the subcommittee clan initially. It doesn't have to go to everyone all at once. So we have each node propose a batch of transactions that are sent to the subcommittee called the clan, a randomized subset of the network. They have to form a data availability proof. DAQC, Data Availability Quorum Certificate, is required for that batch to be registered in our blockchain. Think of this as the information in the block itself, not the batch. The batch does contain all the information of every transaction, but the block only contains the hash of the batch, a single hash that can represent a data set of thousands of transactions. It also has to contain the data availability proof. So our blocks are really small. Imagine 300 or more batches proposed simultaneously, and the block only contains hashes and basically some information to prove that that batch is available in the clan. You have to have data availability in order to guarantee that the information can be executed. Since our blocks are small, and Moonshot does have to work on the entire tribe level, the entire network of Supra does have to execute our consensus protocol. But remember, the heavy payload of the batch data itself, remember, the more information you have, the more nodes you have to send it to, the slower it is achieved. But if you can guarantee with high probability that a batch is available in a single randomized clan, and that there is guaranteed a single honest node available to make sure the data is available to everyone else, you can move forward very quickly here. This is run not by me, of course, it's a team effort, but by PhDs. Supra has like 12 PhDs candidates that are running our experiments. We take a very serious approach to research. We get our content and our research submitted and accepted to some of the top academic venues in the world. And we take this very seriously because any global scale infrastructure needs to have formal verification. Moonshot itself has passed the Microsoft Ivy Checker for formal verification for safety, meaning it is guaranteed, at least theoretically, to never fork or have safety issues. I just want to be careful to be pragmatic and say implementation issues, some of the best teams in the world can still run into bugs. And I'm not trying to pretend that we have everything solved, although we're very cautious around this. So, humility is important. Okay, so moving forward, those clans, these blocks here on the screen, they represent a different clan. So we're going to be talking about how does Supra handle multiple virtual machines at once. Once again, blockchains should be an unopinionated execution environment. We don't have to tether ourselves to only one smart contract language. But how do we have scalability, and how do we execute this in an efficient manner? Well, it turns out that each of our randomized subcommittees called clans can be doing the execution of these virtual machines. How can Supra also be really fast? This is a key insight. Well, in the environment of a randomized subcommittee doing the execution, we only need 51% of those nodes doing the execution. This is very subtle, okay? So traditional computer science and blockchain the last 5, 6, 7 years has been like everyone, 2/3, 67% of everyone does everything, right? And we realized as long as you randomize a subcommittee, this execution can happen in a 51% of the randomized subcommittee. So we can get this done and have the execution and have the proof and with strong guarantees that this has been calculated correctly. This gives us the performance we're looking for. It's the only way to reach global scale. We're going to market with Move language. Move language is going to make blockchain more secure. Developers are going to feel a little bit more comfortable with this, and they will shoot themselves in the foot less often. Let's put it this way. Move language also has the formal verification of the Move prover. These are really, really wonderful attributes. You got to hand it to Mark Zuckerberg at Facebook, right? You know, he funded, I think, was GraphQL, React, and now MoveLang. They're very good at languages, you know, world class. And of course, some of the best teams in the world, Aptos and Sui and Supra, are Move language based. That doesn't mean we discount all that's been built up with the Ethereum virtual machine, the Solidity. This is effectively the JavaScript of Web3. It's not going anywhere. So it's very natural for us to want to provide the service. Why would applications from other ecosystems, Solana, Cosmos ecosystem, Ethereum, Move, why would they want to consider Supra? Well, you can gain access to a price feed oracle, cross-chain communication, automation, on-chain randomness, one stack, single framework, one token. So once again, the whole system is called a tribe, right? And these subcommittees are called clans. And more or less, these different clans, they can be doing different things. They can be doing our oracle service, our on-chain randomness service. They can be executing virtual machines. And these things can be changing, the services that they execute can be shifting and randomly shifted and cycled every period. So the randomization, I can't emphasize this more. It's core to our security properties. In fact, our foundation in Switzerland is called Entropy Foundation for this reason. So Moonshot consensus has to run on the tribe. Everyone has to run Moonshot consensus. We need 67 or 2f+1 nodes in the system to reach agreement. This is mandatory. But the other services listed on this here, on this chart, they can run on the subcommittee level with 51% of the nodes. Once again, to hammer this home, traditional designs in the last 7 years is everyone, 67%, and the entire network does everything. Here, a randomized subcommittee can execute with 51% with strong probabilities, guarantees, at least one honest node is present, so the outcome, if you can hit 51% agreement, is honest, is correct. All right. This is something that, once again, once you see it, it's very obvious. More or less, we have moved into a paradigm of parachains. These are different blockchains. Subnets, these are different blockchains. Layer 2s, different blockchains. These are completely different, isolated blockchains. But at the same time, developers, you know, what is the beautiful thing about blockchain in general is composability, that these smart contracts can interface with each other. But the moment you go into these other, you know, let's call them app chains, Cosmos, Avalanche, Layer 2 strategies and beyond, these are completely different ecosystems. These smart contracts cannot compose with each other. If you don't have composability, you don't have shared liquidity. You end up with all this fractured liquidity. This is why even on Ethereum, all these Layer 2s are competing with each other. They're not necessarily friendly with each other because they're trying to focus on the same limited set of developers and also the liquidity, the amount of funds and value that locked up in their little silo, in some cases big silos. Super containers give dApp developers the ability to have your app chain experience, but on the Layer 1 itself, which has wonderful properties. So app chains, why do folks like this? It gives the builder freedom to decide governance, have their own gas token, set their own gas fees. But the cost is that you have broken composability and thus also broken liquidity. Now with containers though, you can still build your own ecosystem, set your own rules, set your own gas token, set your own price, have your own governance, but tap into Supra's shared security, as well as tap into our price feeds, tap into our cross-chain communication, automation, on-chain randomness services, core primitives that any infrastructure needs. I know this because every layer 1, layer 2, layer 3, everyone wants price feed oracles, cross-chain communication, automation, on-chain randomness. This is clear, right? So imagine if an application can have both. They can have their own ecosystem, their own gas token, set their own rules, but also tap into our enshrined services. So in application developers with Supra containers, you can set your own governance, right? So you can say through any form of decentralized governance, these are the rules to interact with our container. You can have your own custom gas token, meaning in your container itself, you have your own gas, your own token. But really interestingly, you can also map the gas token to operations in your container. So for example, this is a very typical example I like to give. Imagine you're a GameFi application with your own container. And on Supra being extreme throughput, low latency, gas is really inexpensive. We're talking about like fractions of a penny. Suppose it costs 50 cents, I'm sorry, not 50 cents, 50% of a penny or a half of a penny to move an NFT from one person to another on Supra. But in your game, maybe you make it 30 cents. Still cheaper than Ethereum. Well, guess what? That's a 60 times markup from what you paid Supra as an infrastructure provider, half a penny, 60x markup, and that margin is your container's revenue. This is a huge innovation. This creates a new revenue stream for application developers, and they don't have to bootstrap their own network. They don't have to bootstrap node operator sets, worry about economic security. They can go to market with very, very little resources. I do want to mention that we're working on this, and the first containers on Supra will be in the Move language, maybe earliest February, but we're targeting Q1 of next year. So key component, though, that I really want to emphasize is application developers can set their own rules, have their own governance, have their own token, have their own gas, and yet, since it exists on Supra's unified layer 1, we have shared security. These folks can set access policies, say that, yes, I want to compose with these other containers or these use cases. Maybe it's a real-world asset container or some sort of KYC, AML, regulated DeFi container. That liquidity cannot touch Open DeFi. So you can set your access policy rules, very inexpensive to deploy, and yet you have the benefit of having your own economy, your own governance and community. So I'm conscious of the time here. It's been going really fast, so I'll kind of roll through this. Containers are composable, app chains are not. Now, folks have been talking about composability across layer 2s and subnets, parachains, and so on and so forth. It's just not feasible, though. You'll see that there won't actually be atomic. You can have interoperability. Interoperability is different than composability. As a result, those solutions will not actually have shared liquidity. But at Supra's layer 1, the containers are all on the same infrastructure, so we can facilitate this. That's probably one of the major things, because different applications can tap into other ecosystems together and grow together. Zero network setup, you don't have to bootstrap your node operator set. You can just deploy. What we're designing for is to make sure Container Builder is a drag and drop interface, so NFT creatives, business model innovators, business folks, creatives, artists, not only the developer can deploy the logic and set and create your own ecosystem. We want to make this as simple as possible for anyone that has a good idea. And core infra, what we're ultimately bringing together when we're fully mature, single layer 1, different virtual machines, price feeds natively, cross-chain communication, automation, on-chain randomness, one stack. You can tap into it all, single framework, one token. You can go to market very quickly. So I kind of went through these bullet points here. I'll go through them again. The feedback from developers, let's be honest, folks want to have their own gas token. They want to create their own economy. They want to set their own rules. They want to have their own governance, right? We enable cross-container composability, so we have shared liquidity. Based on your access policy, you can also say, no, I don't want to interact with these other containers. You can set the rules. Supra's itself is a high throughput, low latency blockchain. We have talked about other blockchains that are very high performing as well. The thing is, you're going to notice that they don't go beyond 150, 160 nodes. They have performance, and they have really beautiful algorithms. And we do too, by the way. We also have a DAG called Sailfish. But in the end, what we think is really important is decentralization. Can Supra handle more nodes and still have extreme performance? So our test was 300 nodes. We actually want to get beyond 500. And also, we have a strategy to get to the thousands. So containers, though, are coming very soon. It's going to be a huge unlock for developers. Anyone that's considering a layer 3 on Ethereum, my advice is don't do it. That is not good for Ethereum either, despite what these guys tell you. Okay, so let me tell you a little bit more here. We have some of the biggest layer 2 projects talking about millions of layer 2s. How could there be millions of layer 2s when there's like 6,000 dApps on Ethereum? Be careful what you listen to. I know those are kind of sharp words, but let's be practical. It's good for us all to have a very clear view of how the world actually is going to be. So my advice to Ethereum, of course, is to scale the layer 1 itself. Super dApps. I'm going to have to go through this quickly because this is very interesting. Supra Stack is going to enable new things. I see someone in the audience that's wearing an Eigenlayer shirt. We're fans of you guys too. But basically, we'll just move forward. Eigenlayer is bringing vertical integration to Ethereum, right? And we're not the only ones that are seeing the integrated blockchain approach. They have a different strategy. We have a different approach. We are more of a shared security design, not just economic security. But we would love to welcome Eigenlayer to Supra any day. Okay, moving forward here. So keeping my eye on the time here, there are amazing things you can do with a single infrastructure that has a unified shared security, native cross-chain communication, price chain oracles, real-world data, native automation, verifiable randomness, high throughput, low latency blockchain, multi-VM support, cross-chain compatibility, native DeFi. What could you build with this? We're providing the infrastructure, the tools. Developers are going to be building things we could have never imagined. So what makes these dApps that deploy on Supra super? Low latency, robust shared security, simplified DevX, one framework, one token, therefore it's cheaper for builders, and as a result, it's also cheaper for end consumers and users. What Supra is ultimately trying to build is a unified world computer. Everyone talks about a world computer, but you know what? Supra is doing it, in our opinion, is a world computer needs to communicate with the world. A world computer needs to communicate with other blockchains. A world computer needs automation. A world computer should be agnostic to the virtual machine, to the programming language. And that's what we're bringing to market. So kind of moving through this, I probably only have enough time for one example, and then I have to probably come off stage here, although it's been fun. A next-gen perpetual DEX. Imagine if your blockchain had native price feed every single block, zero block delay automation, access to cross-chain communication. Okay, what can you do? Well, what I'm most interested in is enabling new revenue streams and business models. Right now, when there's a liquidation, there's usually an oracle or automation network or an external party that triggers the liquidation. And this actually creates some sort of perverse incentives for folks to collude with the block proposer, the validator, with the oracle provider, with the bridge, because these liquidation rewards are quite high. It could be 1% of millions of dollars. It adds up really quickly. So there's a lot of backroom deals happening right now as we speak. Trust me, it's happening. But imagine if you had automation in the mix and you had price feeds in every single block. You can deterministically, transparently, automatically execute the liquidation. And that value does not have to go through some colluding party. It can go directly to the dApp. The dApp can furthermore redistribute that value to the community. This enables new business models. I also want to encourage dApps and application developers to rev share with the node operators themselves that are doing the application execution, right? So this is just one example of many. I am out of time, but I just want to say that Supra did just launch recently our mainnet. There's a lot more to do. We're on it. We're excited about this. I'm obviously very biased here, but I'm confident that the blockchain industry will absolutely go towards this direction. Aptos is rolling out their on-chain randomness. Sui is rolling out their cross-chain bridge. Eigenlayer on Ethereum is restaking, through restaking, bringing out all kinds of verifiable compute. These are instances of vertical integration. Supra has a design to do this the most effectively in a global scale. India, thank you so much. We love you.